Here's a video hint on how to work homework problem 517. We're implementing a while loop with 4 different implementations where n is either a 8-bit or 16-bit register or an 8 or 16-bit global variable. And I've suggested that you try at least one of them in Texas, but it's a great idea to try all 4 to make sure they really work. Assembly language programming is tricky, and the choice of instructions that are available is different for each of these types, so you might want to try all 4 to make sure that they really do work for full credit. So the while loop that we're implementing looks like this. I like to write it this way so it's a little clearer, but they do the same thing. And the thing to notice here is that we first initialize n, and then we test n to see if it's 0, and then we decrement n, and then we call the body subroutine. There's different ways you can implement a loop that'll loop 100 times, but the order here is important. We first initialize n, and then we test it, and then we decrement it, and then we call the subroutine. So the first time we call the subroutine, the value of n won't be 100, it'll be 99, and then but it will execute 100 times because we'll decrement down to 0 and call it with the value 0 as well before we test it. So let's see how this is implemented in assembly language. So at the top of the Texas subroutine, or at the top of the Texas source file, we need an org 800 to start in RAM to define some global variables. I've selected a global variable called body count that keeps track of how many times the subroutine body was executed, and I've defined the variable n8, which is a global 8-bit variable, and n16, which is a global 16-bit variable. Then we do an org 4000 to start in EEPROM, and here I've put the body subroutine. It's a little unusual. Sometimes we put them at the bottom, but it doesn't matter as long as it's in EEPROM. So body subroutine will increment the variable body count and then return. That's all it does. Just does an 8-bit increment from the memory location body count. So here's the main right here. So this is where the program execution will begin. The first thing we always do is initialize the stack pointer, and then here's the program itself. First we clear for part A, and this is where we're doing the 16-bit global variable implementation. I'll leave you to do parts B, C, and D, or maybe to find a better way to do part A, but here's one implementation that works. So first we'll clear body count, and that's just our counter of how many times we've called the subroutine. And then we'll move the value 10 into the 16-bit global variable n16. And here I'm putting the number 10 in there so we don't have to wait 100 times for it to execute. The subroutine begins here, and that is we load the D register with the value of n16, and that sets a condition code register. So we're testing it to see if it's 0. And if it is 0, we can go to next one and continue down. But if it's not 0, then we want to decrement the D register, or decrement that variable. So we have to subtract 1 in the D register, from the D register, and then store that D register into the n16 global variable. There's not a way to decrement that variable directly. We have to have it in a register. And then we jump subroutine to the body subroutine. So the first time through here, we will have loaded 100 or 10 into it, and then tested it, and then decremented it, and then called the subroutine. And in the subroutine, it just simply increments that body count. And then on return from subroutine, it goes here and branches back and continues for 10 executions of that loop. So let's make sure that this works. We've assembled it, and we'll reset the microprocessor. And here I've got displayed body count and the D register and the n16 variable, all in decimal format. Body count's 8 bits and the others are 16 bits. So if we reset and run, first thing we do is load the stack pointer. So there's a stack pointer at 4000. And then clear body count at 0. Move 10 into the n16 variable, there it is, and then load that into the D register. And now we'll check to see if it's 0, but it's not. So we will subtract from the D register 1, and now D is equal to 9. And then we store the D register into N16, so now N16 is equal to 9. And then we jump subroutine to body, and there it is. We increment body count as 1, and then return, and continue. So if I go down here to the end of that and run to the cursor, it'll run through there 10 times, and now the D counter has gone down to 0, and the body count is up to 10. So this works correctly. You'll have to do the other 4 implementations, or you might find a better way to do this implementation as well. But it is a little bit tricky, so be sure and code it carefully and test it in Texas for full credit. Good luck.